hello, how are you? My name is Anna Tenbensel. Welcome back to my channel. We are here going through as many LeetCode problems as we can in a year, and I am on question number 91, decode ways. Now, I've given myself a 2-minute head start to read through this, but we are going to read through this together, and the solution today is going to be in Python. A message containing letters from A to Z can be encoded into numbers using the following mapping: A1, B2, Z26. To decode an encoded message, all of the digits must be grouped, then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, 1116 can be mapped into AAJF with grouping 1, 1, 10, 6, KJF with 11, 10, 6. Note that the grouping 1, 11, 06 is invalid because 06 cannot be mapped into F since 6 is different from 06. Given a string S containing only digits, return the number of ways to decode it. The test cases are generated so that the answer fits in a 32-bit integer. Then they give us these examples here. The input is 12 or 1, 2. The output is 2. 12 could be decoded as A, B, or L. Same with example number 2, 226. The output is 3, 226 could be decoded as BZ, 226, VF, 226, or BBF, 226. Then lastly, the input of 06, as we saw up here, cannot be mapped into F because of the leading zeros. 6 is different from 06. And then they give us the constraints down here. So now that we've read that, and again, I read this once before, so I had a better idea of how I wanted to start this, I think we can jump into this. So, given this S string, I think I want to do dynamic programming to count the number of ways to decode given the given string S. So DP is going to be the way I'm going to go here, and I want to start off with a base case. So if not S, return 0. So if we have if not S, return 0. Okay. And then I want to initialize N as the length of S, and also initialize a DP list with the length of n plus 1 to store the number of ways to decode substrings of S. So we're going to initialize that here of 0 times n plus 1. And then I want to do this initializing dp0 to 1 since there's only one way to decode an empty string. So we're going to do dpo, but we're also going to do dp1. And dp1 is 1 if the first character in S is not 0. So that will handle cases like this, and also cases where we start with an integer, so zeros and ones. Zeros or actual integers, and we're going to say 1 if S 0, if that makes sense, 0 else 0. Then I think that makes sense. So let's then take, let's see, MS continuing with the, so we need to iterate through the string from this point from the third character to the end of the string, I think. So we're going to say for I in range to n plus 1. For each character position at I, we check to see if it can be decoded as a single digit. So for this, we're going to say 1 digit, or as a 2-digit number. So 2 digits, it's not going to go more than that because we're capped at 26. So let's say, for example, 1 digit is equal, and then we're going to do 2 digits. Yeah. And that's going to be the integer here with I minus 1, and I forgot a t. S I minus 2. So if 1 digit is between 1 and 9, then we add the number of ways to decode the previous, which in this case we're counting as I minus 1 characters to DPI. And if 2 digits is between 10 and 26, then we add the number of ways to decode that. So let's write that down. So saying if 1 digit is greater than or equal to 1, then DPI increments the DPI minus 1. And then we're going to do that same logic with 2 digits. No, we need it to be 10. If 10 is less than or equal to 2 digits, this is going to make more sense, which is less than or equal to 26, then we update the characters to DPI. So because we're going to be implementing this, we'll be able to decode this SI minus 2I as a 2-digit number. So we're going to say DPI DPI minus 2. So all we'll have to do at this point is return DP with that length of n, in theory. So the DPN will represent the number of ways to decode the entire string in S, and should account for the ones we cannot decode, which is the ones that start with 0 or have zeros that cannot be computed. So I think intuition here is right. I'm going to run it and see if I have any errors in this. I'm hoping not. Wrong answer, output 1. Okay. For 226, expected is 3. What is... Okay. So let's take a look here and see maybe what I did wrong. We have initialized n, which is that list, DP here, maybe 2 digits. Oh, maybe I should need to do this as 2 as well, not 2. That should fix that. Okay, see, that was it. I think it's just because I was looking at this a bit. I do that sometimes. I know it's not good to do that. Okay, so I think that should work over here. So let's go ahead and run it. Oh, okay. 82% and 55%. Today's a good day for me. This isn't too bad. This isn't too bad. Okay, so runtime beats 82% of users with Python, and memory beats 55% of users with Python. I'm actually very happy with this. I don't think I need to redo this. Okay, good. Awesome. I hope I explained that in a way that made sense in terms of how I'm viewing the logic of this right now. And I will put this code in my LeetCode Solutions GitHub. You guys, please fork and clone it. Make it better, make it worse, have some fun, learn something new. Yeah, that's what this is all about, is getting better. And I'm trying to get better at explaining these things so I can do this in front of people live. So getting speed, getting accuracy. So any suggestions, comments, questions, corrections, I happily will take, especially in the comments, or if you want to drop it in the GitHub. Or if you have a different approach to this that didn't use DP, like a DP like programming, I would love to hear like what solution that was and how effective it was for you. So thank you guys so much for watching. I appreciate you all so much, and I will see you in the next video. Goodbye.